Hello, my name is Luis Roca and I'm the head of the compounding department, and I'm going to show you in this presentation how compounding can be the tool for innovation in the plastic industry. To do that, I will follow this outline. First, we will introduce a little bit about the concept of innovation. Second, we will talk about the innovation and compounding. We will go on with success case studies that we have developed in IMPLUS, and to finish, we will share our conclusions. Research and innovation. Okay, these terms are very known, but you can find a lot of definitions. We can summarize as the research and innovation can be the result of efforts to make a product or brand stand out as a provider of unique value to customers in comparison with its competitors. Okay. At the end, what we are looking for is differentiation. Differentiation to make our company different and able to offer products with added value that our competitors cannot. And how to do that? The only way to make differentiation is research and innovation. Now we are going to talk a little bit about research and innovation. What is research, innovation, and so on. First, what is research? Research is a systematic investigative process employed to increase or revise current knowledge by discovering new facts. And we can find two different kinds or two different aspects of research. Basic research that is mainly based on the increasing of the scientific knowledge, and applied research, which is based on the relationship between the basic research and the need for solving problems, developing new processes, products, or techniques. Nevertheless, both techniques or both aspects are a little bit far from the market. This close to the market is more related with innovation. Innovation will bring these developments to a product or to something that a customer will pay. At the end, what we have is time, ideas to make profit in our company. And how is related to the compounding process? Well, first of all, I will describe a little bit about the compounding process just to make you understand and all the relationships, okay? Well, this is a scheme of what will be the compounding equipment that will help us to describe the process. First, we have a mixing device, two-in-a-square extruder in this case. Second, we have the feeders that will help us to make the recipe. And third, we have the bath and pelletizers that will convert the product in pellets to be employed in the plastic industry. So, first, we have the polymer. The polymer, we can employ the polymer that we want, depending on the properties that we are looking for. That will be complemented by fillers, by pigments or additives, or by fibers, depending, once again, of the properties. All together will be mixed in the two-in-a-square extruder or in the mixing device to obtain a final product, which is a final compound, to be employed by our customers. And which is the innovation basis in the compounding process? Well, we can find four kinds of innovation in compounding process that can be completely related with all the steps of the chain value. First, we can make innovation in the product development, creating new compounds. We also can make innovation on the production or in the process to increase productivity, to increase quality. We also can improve innovation, we can improve the management by innovation, or we can innovate also in the service improvement. All of these 4 points are very important, but we are only focusing in the two first, which are more based on basic research, on something that can give more added value. The other aspects are more related with logistics, administrative issues, and service to our customers. So we have to think in materials, modifying the equipments to increase our profit once again in the company. And which is the concept that we are going to follow to do that? The concept is based in different points. For the first point would be that plastic matrix can admit a great variety of third materials. I showed you before. Fillers, additives, fibers, synthetic, natural, it doesn't matter. Plastic materials as matrix can also be converted in infinite shapes and designs. Altogether, will give us a lot of possibilities to make new products with advanced functionalities. But we need to find the right plastic, the right additive, and mix them in the adequate way to success. Otherwise, we won't fulfill our customers' requirement. How can we innovate on compounding products? Well, we can add new properties to our products, to our compounds, by adding, as I said, new additives filler of pigment. For instance, as we did in A+, graphene compounds. Now you know graphene is in fashion, is the material of the future. We need to develop new materials with graphene. We have to move from our competitors adapting to new regulations. If we need to go to other markets in a world that is completely globalized, we have to fulfill the requirements of other markets, other countries, other regulations. One example, REACH regulation in Europe. We have to employ new additives never used in plastics, for instance, employ in paints, employ in rubber, employ in wood or in ceramics. In this case, insecticide employed in plastics, as I show you later. We can shift from conventional polymers to bioplastic ones, once again, because we want to make differentiation or because we are obliged by regulation. We can make tailor-made bioplastics. Or adapting to emerging technologies. For example, the most known emerging technologies is 3D printing. We can do research or we can do innovation modifying the materials that we are going to employ to make 3D printing. From the point of view of process innovation, compounding can also give a lot of possibilities. We can modify our equipment to be more effective, online monitoring. We can achieve that by sensoring the machine. We can define realistic ways of dispersion to improve quality. We also can optimize production and process by simulation, time reduction. It will make us be more efficient. Okay, this is very related with the new industrial revolution, Industry 4.0. And this is the new challenge for the factories of the future. To employ our equipment in other processes, diversification. In this case, one example could be reactive extrusion. We can make our own materials, being independent of big players. And which companies can take benefit of this innovation and compounding? Not only compounding companies. Suppliers to introduce new additives, pigments, fillers, and fibers. Compounding, of course. Compounding companies can increase their portfolio with new compounds. But also injection or extrusion companies that can take ideas or needs from the final or end users, and obviously end users, that will incorporate in their final product items made of plastics, as you can see in the last slide with this car, with this huge amount of plastic parts with different functionalities. At the end, all the chain value can take benefit of the compounding innovation. And now I'm going to show you different A+ successful case studies. The first one will be metal replacement and Joule effect. Okay, as you know, Joule effect is the consequence of passing current through a conductive item, and the main consequence is the release of heat. And we can employ this phenomenon to make heaters. Okay, so electric conductive plastic compounds can replace metal-based heating systems. For instance, working with polypropylene, we can reach temperatures around 70-80 degrees. For polycarbonate, we can achieve temperatures even higher, 100 degrees Celsius. Or if we want more, let's say, special properties of heating, we can work with high-performance polymers, reaching temperatures around 200 degrees Celsius. Heating times are very short, 2 minutes, 3 minutes. And we have, furthermore, the freedom of designing and rapid production that plastic gave us. The power consumed is equivalent to metallic existing heaters. Now I'm going to show you a video where you can see the effect of heating. We have placed a conductive sheet, and we record the evolution of heating with a thermographic cam. In the top right corner, you can see the temperature, which is very close to room temperature, around 30 degrees, and it starts heating, and you can see the change of the color, going to brighter colors as the heat is rising. Okay? At the end, we will achieve temperatures around 80 degrees. In this case, we have this temperature because we are working with polypropylene, but as I mentioned before, we can change the polymer. We can change the amount of filler or the type of conductive filler, and we can reach different temperatures. Here you can see in this slide how we have reached temperatures around 80-85 degrees Celsius. Moving to another case study, we are going to describe now the insecticide effect of plastic products. You know that plastic is a material that can admit a lot of additives and also admits the release of additives by migration. Then we are going to use this concept for this new application. Then we are going to employ these compounds to obtain different shapes, different products like films, pipe profile, foam things, and so on. And then we can adapt our insecticide effect to any scenario, using different shapes of plastic items. And in place we have developed a system to avoid degradation of insecticides in the process of compounding. This allows us to add different kind of insecticides depending on the insect that we want to kill. This methodology allows insecticide effect lasting for different periods of time, which is also very interesting. Here in the video you can see once again a test of killing effect. Here we can put mosquitoes in this specimen, and after a few minutes we have the mosquitoes start to being dizzy, like in this slide, and after minutes mosquitoes are completely died. Another important application or case study is related with one of the technologies, more promising technologies that we have nowadays in the market, which is 3D printing. Okay, we have the chance of making advanced 3D printing filaments to obtain advanced properties. So we can develop rods or filaments with special properties or effects like electrical properties, antimicrobial, boot-like, water-soluble, among others. We can customize new properties depending on the additive. We have the skills to add many additives to plastic and to obtain special rods or special filaments for 3D printing. We can make the studies for this new rod material, how to process, how to increase the effectiveness, and so on. Then here we have developed a base for a lamp that we make the switch by touching with 3D printing material that has electrical conductivity. We have made another developments. We don't have enough time to talk about everything, but we have made developments decontaminating recycled plastics, making hydrosoluble solutions in PBOH, starch-based bioplastics and blends of bioplastics, sustainable flame retardancy, natural fiber reinforcement, thermal and electrical conductivity, as I showed you a few minutes ago, polymer synthesis by reactive extrusion, among others. To conclude, I would say that compounding is the most powerful source of innovation in plastic industry, as I have demonstrated to you. Plastics can admit a lot of natural or synthetic compounds, additives, fibers, fillers, or whatever. We have thousands of possibilities to innovate and create new products. This innovation can be compatible with design and process. We can make all together. We can change the properties, we can change the design, and also we can improve the process. It's the most difficult strategy to copy. We have a lot of background to be acquired by our competitors. Can be driven by any step of the chain value, from raw materials, passing for compounders, converters, and also final users. No limitation for any company if there is partnership. Innovate with us on materials. You will be different. Thanks for your attention.